Okay. I know that I asked Vladimir to. I was kind of curious about last week. Vladimir talked about the Lesage theory and also about gravito-electromagnetism, and I sort of wanted some clarifications. And Vladimir sort of suggested that he would give us a little brief discussion on those two topics. And so that's what I'm inviting Vladimir to give a little bit more detail about what he was talking about. And both of these subjects are, I know a bit more about the LaSalle theory, but gravito-electromagnetism sort of, from what I understand, is part of mainstream's thinking. They view it as a subset of general relativity, which kind of don't really understand that. And I did look at Wikipedia's discussion. It seems like there's some confusion and not everybody's on the same page, but that was just my impression of reading. So I'm going to let Vladimir go ahead and talk. So we need to press share and go through the routine.
Sure. Thank you for introduction.
Okay, we should be ready to go. I approved it.
Okay, hopefully I will see my screen.
You haven't gotten the choices yet?
Can you see it?
No, you have to select. Did you get to the screen where it says you select the...
Okay, let's go back a little bit. Here. Okay, now I can, the second time share. Then I will put this one. Share.
Okay, so you have the presentation open on your computer.
Yes.
Oh, there it is.
Can you see it now? Can you see it now?
Yes.
Okay, good.
Okay, can we...
Harry asked me to discuss... Okay.
Can we zoom in on it a little bit? Do you have like a full screen?
You can click the slideshow, which is the sort of
icon
on the right-hand side at the bottom.
Oh, yeah.
Okay, let me see slideshow. Maybe I will see this can be better. Yes, a little bit better. Okay, I don't stop. Okay.
All right, let's go.
Right now, guys, it will be only 4 slides and without many information. I will talk about these 2 very important phenomena. Okay? I will try to explain them in the shortest and simplest way that it will be clear for everybody, practically without mathematics at all. It's ideas. And let's start from the beginning. Gravity. In 1687, Isaac Newton used the Latin word gravitas, weight, for the effect that would become known as a gravity, and defined the law of universal gravitation. It was in his Principle and published in 1687. The theory of gravitation is a kinetic theory of gravity, originally proposed by Nicolas Fatio, push shadow gravity with ether corpuscles, and later by George Lesage in 1748. They were genius. Why I mean genius? Because 3 years passed only after the Newton's known genius, equation, and immediately it was proposed the mechanism how to explain attraction of 2 masses to each other without any force. It is not force. It was proposed push shadow gravity. Where is the force? There is no force. But it was explained why all the masses going together. they are going with attraction, like they have attraction. They don't have attraction. It is not. This is not. It is not a force. It is a push-shadow gravity. The theory proposed mechanical explanation for Newton's gravitational force in terms of streams of tiny unseen particles, which Lissajous called ultramundane corpuscles, impacting all material objects from all directions. According to this model, any two material bodies partially shield each other from the impinging corpuscles, resulting in a net imbalance in the pressure exerted by the impact of corpuscles on the bodies, tending to drive the bodies together. Let me tell you that Lissajous practically used the same push-shadow gravity, but instead of ether corpuscles, he put a new corpuscles. And what is important, he tried even to explain this mass and all these equations accordingly. I will show you on the next slide what he proposed, how he developed the Fatio idea. Theory of gravitation. Lissajous proposed quantitative estimates for some of the series parameters. This is his development of this idea. He called the gravitational particles ultramundane corpuscles because he supposed them to originate beyond our known universe. It was a genius prediction of universe-created particles, xions, what I introduced in World Universe Cosmology. The distribution of ultramundane flux is isotropic, and laws of its propagation are the same as that of light. You see, in my model, I named what we live in the world, but I can name it as a known universe. There is a universe and there is a known universe where we live in. But it's confusing people. Known universe, that's why I introduced this word world. We live in world, not in known universe, like Lissajous proposed in, oh my goodness, close to 300 years ago. He suggested that these ultramundane corpuscles might move at the speed of light. I will tell you what does it mean in my model later, in the next slide. To maintain mass proportionality, ordinary matter consists of cage-like structures in which their diameter is only the 10 millionth part of the mutual distance, so the particles can travel through them unhindered. In order to achieve exact mass proportionality, as in Newton's theory, the ultramundane flux must be infinitely intense. It is his model, it's his theory, I'm following it, and I will developing his theory in my model too. Lissajous theory of gravitation is the very first theory which defines the gravity as an emergent phenomenon. It's a very important point. It's a very important point. Let me stress your understanding of this model and what we must take for the next slide. Mass, it is not something from the sky, no. It is the result of impinging effect of a many tiny corpuscles through these masses, and this is a phenomenon, emergent phenomenon, as it is the mass as the result of this effect of many tiny corpuscles interacting with this object. You see what does it mean? Gravitational mass, it is not something, from the sky. It is the result of the interaction of the cosmic medium particles going through this object. And as a result, we have this mass. Gravitation and force of gravity, it is a result of the same emergent phenomenon, the same result of this impinging effect of these corpuscles. You have less pressure between these masses than outside of these masses, and they're going together mechanically. Let's continue. I'm very sorry for my emotions because it was a genius idea. Why we killed it? because we rejected ether. There is no corpuscle, there is no particle, there is vacuum. That's why in 1905 we killed everything, including theory of gravitation, and invented this space-time curves and all this equation. We don't need it. We must take this the theory as it is, as it was already, and we killed everything, the whole classical physics, including such theory of gravitation. Let's continue. Gravity in WC, World Universe Cosmology. Existence of the cosmic medium is a principal point of WC. There is no luminiferous, ether, perfect fluid, or vacuum in WC.
Can we possibly stop and discuss the first section before we go on to additional sections that are built upon that?
I don't afford for the slides. It doesn't matter for me. I can continue. Please ask the questions about the previous slide. Next. Where are you? I don't know.
Did you have a question, Cornelius? No?
Mute. He's mute.
He's mute, yes.
Okay, so,
Unmute.
all right. Let's go ahead unless somebody wants to ask the question.
Okay, I will answer.
Yeah, I'm back. I'm sorry.
I have a very short.
I'm sorry. I'm back. There was an issue with my screen covering up my mute button. I couldn't get to it. But no, I had a question. I mean, Lasage theory has been talked about quite a bit in the past, and it's mainly been discounted as a possibility. It relies on the particles that you're talking about never colliding with themselves and being totally invisible to themselves, and that's the biggest issue that I have. I think it's a very good theory as far as quantizing the energy density, the gravitational density of space. It's good there. Where the particles go once they encounter an object, where they come from, those things are unanswered. So there's a lot about it that's unanswered as far as a physical, mechanical theory, but there is the actual usefulness of the quantization of energy distribution using it.
The questions, what I could answer after the next slides. Let's continue, and then I will answer your questions, because you know I did start even my model. I did start even, and you asked already these questions. Let me start, and then we will talk about my model and what is my understanding of this Lesage theory of gravitation. Because I'm following, and I have some, some development of this idea. Idea the same, nothing new, but the execution of this idea a little bit different. But let me continue, because then it will be easier for you to understand what I'm talking about, and I will answer this question immediately after. We have 40 minutes, guys. Let me finish 4 slides only, and then we will have the total time of discussion and answering your questions. Okay.
Yeah, I won't be here at that time, but I'll review the recording if it's going to be recorded.
Okay, let's continue, and then I will answer this question later, a little bit later, 5 minutes, not more.
Yeah, I've got to leave, so I'll watch the recording. Thank you.
Time, space, and gravitation relate to the impedance, gravitomagnetic parameter, and energy density of cosmic medium, respectively. It follows that neither time, space, nor gravitation could be discussed in absence of cosmic medium. Gravity is not an interaction, but a manifestation of cosmic medium. There is no cosmic medium, there is nothing. There is no time, there is no space, there is no gravitation, there are no masses and all this stuff. Without so-named ether, because cosmic medium is some kind of ether, you cannot talk about anything. Not with formulas S multiply M and all this stuff. Nothing. There was nothing before the creation of our world. And even in our world, we started to to name even these, to define these parameters, these very important definitions, only after 10 to the minus 18 seconds, when the first ensemble of particles was created, and we can introduce the notion cosmic medium. You see, there is no T0, there is nothing before this 10, before the first ensemble of particles inside of the world. Nothing. Space, time, gravity doesn't exist. WC is based on cosmological time tau that marches on at the constant pace from the beginning of the world, known universe, as I told you, up to the present epoch, along with time-varying cosmological parameters, including Hubble's parameter H, which are inversely proportional to tau, namely H equals tau to the minus 1. The value of H should be measured based on cosmic microwave background radiation data only. There are some questions about cosmic medium exists or not. Of course it exists. Many times I told about fast radio burst. Maybe nobody knows what does it mean, this effect. You have far away from us some explosion of a very huge object, half galaxy or something like this. And it extracted some radio waves going from this object to us. And then we have in Australia usually some telescope, very good one, and it measures the upcoming pulses at different frequencies, at different wavelengths. And what they found, there is some delay between components of these radio waves from this far away object. And you have higher frequency, less wavelengths. It's coming before the next one, and so on and so on. They calculated even this delay in these components based on standard plasma physics. And I've done the same, believe me, guys. And they found a very good correlation between this delay and the concentration of intergalactic plasma, which is 4.8% of overall medium energy density. You see, it exists. We cannot cut it. And it's a well-known phenomenon, fast radio burst. Guys, go to Wikipedia if you don't know this. It is a principal effect he shows. The second very important point, microwave background radiation. We have already 50 years, I don't know how many years already passed, even more. It exists. Where it is? It is in a cosmic medium. Why are we talking about there is no medium, there is now no ether, or whatever? Of course it is. And we exist in it. And what is important, even the concentration of our ordinary matter in the medium, 4.8%. And in all the macro objects, including you guys, it's 2.4%. Even in the medium, we have ordinary matter much more than in all the objects, galaxies, planets, and all this stuff. And nevertheless, we're talking. There is no medium, there is nothing to talk about. There is microwave background radiation, there are fire. Don't need more. Two effects, two phenomena, it's enough to confirm, to prove that there is no vacuum, there is no perfect fluid, there are some very interesting effects showing us even standard plasma physics based on protons and electrons. There are even these ordinary particles inside of our cosmic medium. Why we neglect it? Why we don't to reject what we don't now know about it? Please increase your knowledge about these two effects, microwave background radiation and fast radio burst, and you will be immediately convinced that we live in a cosmic medium. Sorry for my emotions. In WC, the time-varying gravitational parameter G, proportional to tau to the power -1, is proportional to the energy density of cosmic medium, which has the same equation. It is not a constant. That is why WC aligns gravity with Lesage theory of gravitation. There are no choice. If you have your medium and it's filled out with some particles, and you have energy density of this medium, and I found that gravitational parameter G is proportional to this energy density of the medium. How we can go around Lesage mechanism? How we can go with the general relativity with this constant G? We don't know where it came from even, That's why there are no choice. Based on experimental results, on experimental physics about microwave background radiation and fast radio bursts. In WC gives Lesage theory of gravitation the following parameters. I developed the notions of its parameters. Psions with rest energy 5.3 microelectron volts are the ultra-relativistic universe-created particles, ultramountain corpuscles, which created by the universe beyond our known universe. Speed of a gravitational change propagation is about c, which is the gravitodynamic constant. It's a very important point of my model. First of all, psions, they exist. First of all, they impinge all the masses because of this interaction, big interaction between them and the objects. What we have around is there is mass. What is important? Psions, they don't exist and so on. Absolutely wrong. They interact with each other if there is a good, high concentration of them. And as a result, we can observe so-named 21 centimeter wavelengths radio waves. This is the explanation of these psions. We have all around. We have so many objects, including dark galaxies, that they radiate these 21 centimeter wavelengths. These psions are responsible not only for Lesage mechanism of weak interaction with all the objects, but for the self-annihilation and irradiation 21 centimeter wavelengths radio waves. You see, that's why it is not something from the sky. On the contrary, they exist. The second very important point, that the gravitational change propagation is about c, which is a gravitodynamic constant. Why it is? Millions of people they're talking, maybe gravitation they have an infinite speed or something else. No. According to the Lesage mechanism, is proportional to the speed of these impinging corpuscles through the masses. And why it is close to C, gravitodynamic constant? Because they're ultra-relativistics. All these particles, they have a rest energy that provide them. Ultra-relativistics means very close to parameter C speeds. That's why there are two answers immediately. First of all, why is C, and why there is interaction propagation, so-named interaction, close to constant C, and it is not infinite. It's not infinite. It is have a very defined speed of this impinging effect from two masses, and you can do something with one mass. You will see only after some time C multiplied on tau that there will be influence on the second mass. Proposed weak interaction between psions and other particles provides mass proportionality, what I told you already. Energy density of psions in the world is about 64% of the total energy density and provides high intensity of their flux. You see, even this, high intensity flux, what is very important for this effect, it's provided by the composition of the cosmic medium of the whole world with 64% of the total energy density. You see, 2/3 of the overall energy density, it is inside of these particles. Gravitational mass, mg, is a classical notion that defines gravity, the emergent phenomenon. we emphasize that an inertial mass mi, that is a coefficient of proportionality between a force F and acceleration a, F equal MAI, has nothing to do with mg. It's two different masses. One of them, emergent phenomenon, depends on the particles xeons, and another one, in our lab, we measure acceleration and mass. What is the correlation between them? Nothing. Einstein developed general theory of relativity starting with the assumption that inertial and passive gravitational masses are the same. There is known as equivalence principle. First of all, I don't understand what does it mean, passive gravitational mass. I don't know what does it mean. Inertial, okay, at least I have some second law of Newton to find what is the coefficient between acceleration and force. But what does it mean, gravitational, passive gravitational mass? And Einstein, he doesn't explain it. No, there is nothing. But assumption, and it's a principle, equivalence principle, based on what? On nothing. Okay. I finished my short presentation. I tried to be short and as maximum, as simple to explain Lesage gravitational theory and how I improved it, increased, developed this model inside of my whole universe cosmology.
Okay,
now I'm ready to answer all your questions.
We got 4 minutes here.
We will continue. We can continue next half hour. I have four more slides. Oh.
Okay, I'm kind of struck by a little bit of the similarity between what you and Andy are saying, and you talk about the energy density of the universe seems to be a fundamental idea. Is that correct, or would I be wrong in saying that?
It's correct, because if you have your medium, immediately you have parameters of this medium. Impedance, magnetoparameter, gravitomagnetic parameter, and energy density. You don't have medium without energy density. You see, it's a parameters of any medium, including air around us. We have energy density as a result of a cosmic medium. It's a parameters of cosmic medium. That's it.
Okay, so you're saying that what I said was kind of correct?
It's not correct, because don't compare to his theory. I didn't understand it at all. I'm sorry, man.
All right. But I see a similarity there. I'm not sure whether other people see it or not, but I think Andy is talking.
I definitely see it, what you're seeing. Same thing. I just don't speak the language, man.
Yes, that's what I...
If you can see similarity, I'm so happy, because you started maybe earlier than me. I started to develop this model 24 years only. I started to publish my papers, many papers, 12 years ago. That's why it took some time for me as a physicist, and I'm Doctor of Science in Physics, for 24 years to develop this model.
No, I notice you say a lot of similar things too, and you're also looking at the history of where all these things came from, which is pretty much core to what I do. Is trying to understand the assumptions.
You mentioned the Lesage. I don't know where you took it from. And ask your ChatGPT, what is the coincidence between your model and mine? And I will be more than happy to hear next time based on this artificial intelligence. I have my own intelligence. I don't have artificial. Of course, I used it, but the ideas can come from your brains only, not from intelligence, artificial intelligence. I'm sorry.
Send me the PDF. Send me the PDF so I can copy the text, and I'll cut it right into GPT-01, and it'll give me a summary of what you're talking about. It'll parse it down into a way I can understand it.
Do me a favor, then you will understand, and maybe next time you will report the result of your conversation with IE.
Yeah.
Okay, good, guys. Ask me all the questions, because I want to be absolutely clear with my main ideas: cosmic medium, gravitation, and who is responsible for it. And don't say these particles, we don't see it. all my universe-created particles produce self-annihilation. It's their most important effect. And you have, as a result, different wavelengths in our cosmic medium, in our eyes, and all this stuff. Guys, please, please, accept the existence of cosmic medium filled with different particles, and there are experimental results. They show their existence. Self-annihilation of all these particles. And in my papers, I showed a lot of experimental results that coincides with the rest energies of my introduced.
All right, we're gonna end here. We're gonna end here pretty quickly here.
Okay. Please continue next session.
Well, I have a quick question.
Yeah, but you're going to get cut off.
Well, really quickly, I don't understand how invisible particles that travel into every direction can cause the apparent force of gravity. What mechanics are going on that would create that illusion?
There is no gravitation interaction between particles. Forget about it. It's a bullshit. Particles, they have only...
particles create...
There is no gravitation. Forget about it.
Well, the invisible particles that travel into every direction, why would that create the effect of gravity amongst objects?
You know, we have these molecules going around.
All right, well, we're back. I think Jerry's question is, I think that the point is that there's a difference in pressure of all these particles, and it's this pressure difference which shows up as gravity. I think that's the answer. Does that help you any, Jerry?
Well, why would that cause the motions of objects in any direction? The presence of unseen particles that travel in all directions. Why would they push objects? Or
yes. The objects are pushed together because the pressure is less between them than push. The pressure pushing them apart is less than the pressure pushing them together.
So these particles have a physical existence. So as they interact with these physical actual objects,
there is a weak interaction. You're absolutely right. Weak interaction between these particles and the particles inside of this macro object. It's very important because gravitation, it's a classical physics means ensemble of particles. That's why you have objects consisted with particles of ordinary matter and universe-created matter, and you have impinging particles that they have a weak interaction between them, between all of them. Yes, there is weak interaction. That's it, what they have. They have self-annihilation. It's one effect of these particles. And the second one is weak interaction with all the other particles.
I've previously observed some similarity at any rate, between this amalgamation or analogy between gravitational forces and electromagnetic forces with the work of J.P. Wesley, who has similar equations for things like energy density and the effective Poynting vector. So I'm just wondering, I'm not sure if you've looked at that very much, Vladimir, but I'm wondering, is there any similar idea with regard to how electromagnetic forces might be brought about by particles pushing things together?
We'll talk about Maxwell equations in my next presentation. Please have your patience. I will answer you this question, and you will see. It's only 4 slides only. Guys, I'm trying to, in the simplest and shortest way, to explain you very critical points for the classical physics overall. And what is important, I rely on the history of classical physics, which was killed in 1905. All of them, genius people. I will start with the next genius guy, and you will see his advantages, achievements, and what is important, His ideas were killed in 1905, and everybody forgot about Lesage, about all the genius physicists. I'm very sorry.
Okay,
That's why I will
make,
answer this question in the after next presentation.
all right, I want to make a little comment here, and that is I did go to Wikipedia. I think I mentioned that earlier in the introduction. And I looked at the article on Lesage, and it was quite extensive and covered a lot of detail. Apparently, there's a lot of work that's been done on this. I know that it says that Lorentz was involved. There was an attempt to interpret the Lesage theory in terms of electromagnetic waves. And then at the end, and this is the kind of the part that got me at the end, there's this little paragraph that says, well, people aren't interested in this anymore, and and it's fallen out of favor, and there was no explanation as to why. And that just kind of put up a red flag for me, like, why is this not in favor? It's like Einstein's theory is better, and this theory fell out of favor. And I'm thinking to myself, well, give me a why, give me a reason. And I didn't see a reason. And so that's kind of where the Wikipedia leaves it, and it kind of is unsatisfactory as far as I'm concerned. So that's my view of it. Why is this not acceptable to the physics establishment? That's kind of the question I don't know. Maybe we should try to find out why. What makes them think this is a bad idea?
Well, that's my presentation, guys. I will answer your question, Harry. It's a very good point. It's a very good red flag. And it's not responsibility of Wikipedia. No, man. It's a responsibility of existing classical physics around, of a mainstream physicists, mainstream scientists. I don't know. It's responsibility. It's only library. That's it. Don't blame on it.
Well, my point is, they obviously have, the consensus of opinion is obviously that general relativity is great and wonderful and solves all the problems, and it's the best thing that ever happened to physics, blah, blah, blah. But, it's an absurd theory based on, well, as Roger was trying to say yesterday, it didn't make any sense. You start off with special relativity that doesn't make any sense. Special relativity doesn't make any sense. So how can you have a theory of gravity based on a theory that doesn't make any sense? Okay, that's a big...
There is not only sense. There is no logic even. You know what? We have microwave background radiation. We have our fast radio bursts. Nevertheless, we claim there is a vacuum around us. So that's it. There is no cosmic medium. That's it. Simple as it. Where is the logic?
Well, my explanation of this is that, and I talked about this before, that they go back, and everything that modern physics is based on is this idea of Democritus and Leucippus back in the Greeks. And Democritus and Leucippus said that the void exists, and the only things that exist are atoms moving in the void. And they've essentially held on to that idea forever. And essentially, they can't change their ideas because they're holding on to the old ideas. That's the old idea. Aristotle was wrong when he said there was a medium. Okay, so they're committed to saying that Aristotle was wrong. Okay, because Aristotle's idea was there was a medium. There wasn't a void, empty, vacuum, nothing. There was a medium, according to Aristotle. Well, they said he's wrong, and they can't go back on that idea. They're completely committed to the idea that there's this void, vacuum, nothing thing that exists, and matter moves around within it. And that's their idea, and they're not giving it up.
Follow the money.
That's my...
We are not in the business of money right now. Let me first of all say, Harry, you're absolutely right. The second very important point. Nobody knows history of physics like you, like myself, after 24 years of of reading of all these papers, finding all these genius people. Nobody even talked about it. Nobody named even these guys. And let me introduce another genius guy in my next presentation. You know,
right.
It's very important. We cut all the genius ideas, including, by the way, about these binary systems and all this stuff, a lot of ideas, because we put our general equations, general relativity equations, we cut our vacuum because it doesn't exist, and so on and so on. You know, our modern physics, it's a stop of our classical physics in 1905. This general relativity delayed development of classical physics for more than 100 years. I'm very sorry. This is my opinion about it. That's why we must, together with you guys, recover classical physics, come back to the great ideas of genius people that were before this. Special relativity, general relativity, all these, mathematical, geometrical theories. Our real life, it's a physical life. It's a physical objects around us.
All right, I think we're in agreement that this magic date, 1905, that seems to be Einstein's.
It's horrible. It's horrible.
Right,
it's very
yes.
good theory. I have no problems with his equations even. I will talk about this later a little bit. But what is important, what they put inside of these equations, I mean theoreticians, it's horrible. It's totally wrong, absolutely wrong. Our real world totally different from their expectations. And it's no logic even. There is a vacuum or there is a medium. There's a vacuum and that's it. Forget about it. I'm not
Okay, let's move on to heavy side. All right.
Let's go with the second presentation, and you will see I will try to answer all these questions about electromagnetic and gravity, electromagnetism, what does it mean, and you will see what the real picture before 905.
Okay.
Share, send request.
All right, I approved it.
Now let's go share this one, and let's continue, guys. Share. With Julia Sargent, and then it will be 4 slides about new idea, gravity, electromagnetism. Maybe a little bit less. Heavy side. Who knows about this guy? Somebody heard this name or something like this? Nobody. There is no heavy side in our books, textbooks and all this stuff. But it was a genius guy, and let me introduce this genius guy to you. Oliver Heaviside was born in 18 May 1850, February 25, was an English mathematician and physicist who invented a new technique for solving differential equations, equivalent to Laplace transform, independently developed vector calculus, and rewrote Maxwell equations in the form commonly used today. Maxwell formulation of electromagnetism.
Excuse me, Vladimir. I'd like to make a few comments here about Heaviside, who I know quite a bit about. Heaviside was not an educated person. He's sort of similar to Andy. He was a self-educated guy, and to call him a mathematician is he wasn't educated in a traditional way. He's a self-educated guy, practical person who taught himself mathematics and invented the mathematics that he used. So that's really what's really impressive about Heaviside. So go on.
Let me give you one more comment. There is another genius guy, I like him very much, Nikola Tesla. And everybody talked about him as an engineer, he invented something, and nobody talked about him as a scientist. You know, Dirac, Nobel Prize laureate in physics, he's a crazy guy. He invented this general gravitational parameter that depends on time. You read different text, different article about Oliver Heaviside. I read what I read. I'm sorry, and I formulate from some text. Let me continue, and you will see he was a very genius guy. Maxwell formulations of electromagnetism consisted of 20 equations in 20 variables. It was absolutely impossible to take all these equations into one picture. Heaviside employed the curl and divergence operators of the vector calculus to reformulate 12 of these 20 equations into 4 equations in 4 variables, the form by which they have been known ever since. It is like he knew nothing about vector calculus, he knew nothing about this one, but we don't know even that Maxwell equation we used to have right now. It's only because of Heaviside. Only he could reformulate. Of course, he was not a mathematician. He invented this, operators, curve and divergence. He put these vectors, he put the contemporary view of equations, and he was nobody. That's why please change your text and go to some other text like I found it.
Sorry to interrupt, but surely he didn't invent curl and div and grad. He used them to great benefit. But I mean, they were developed much earlier by people
You're absolutely right.
Hamilton and Gibbs.
One second. I didn't tell that he invented curve and divergence. He applied it. But it was written before, and I will show you. He independently developed vector calculus and rewrote Maxwell equation. Vector calculus independently developed. And then he took some existing operators and put them into the existing 20 equations with 20 variables. It's totally impossible to imagine this picture. And now you have your 4 equations with 4 notions, and that's it. Simple like this. And only because of him. Let me tell you the next question, the next sentence, and you will see the opinion about him. Although at odds with the scientific establishment, you see, it's very important. For most of his life, he changed the face of telecommunications, mathematics, and science. You see, as I named already, Nikola Tesla, Paul Dirac, all this, they're outside of a mainstream scientists. Immediately they are crazy, they have odd scientific establishment, I don't know, guys. I'm very sorry for these genius guys that not only forgot, but they blame for nothing. They were genius against their time. That's why I'm trying to show you all these guys, and they forgot for what? For nothing. Let's recover them. Let's use them. Let's pay tribute to them. Oliver Heaviside published the equations for gravity-electromagnetism, I will continue with this one, as a separate theory expanding Newton's law. For me, it's a very important, idea. In 1893, and I referred even at his particle of 1893, ahead of Einstein's general relativity, which is the geometric theory of gravitation. You see, that's why even he transferred so-named, Newton's laws into the gravito-electromagnetism, that it is an element of electromagnetism. And I will talk with the next slide, what is the difference between them. Next. Maxwell equations. Oh, it's very important to show you something in history of our life. Maxwell in physics. Maxwell equations form the foundation of electromagnetism. Their value is even greater because Swain showed that linearized general relativity admits a formulation in terms of gravito-electric and gravito-magnetic fields that closely parallels the description of the electromagnetic field by Maxwell equation. There is a reference. So what is important? Theory pointed out this analogy on the formal analogy between the basic electromagnetic equation and Einstein's gravity equations in a first approximation paper published in 1918, 3 years after general relativity. Immediately he showed that there is no difference between general relativity equation and Maxwell equation. It's the non-linear Maxwell equations. I'm an expert in optics, you know. There is so-named linear optics, and there is non-linear optics. Non-linear optics we have when we have a laser radiation with high intensity and all this stuff. The same story with general relativity. If you have weak gravitational field, and all our objects, they have a weak. You can use gravity electromagnetism without general relativity. General relativity is a non-linear equation. It means the gravitational field must be like a laser beam, very high intensity. Then you must go with general relativity because there are some non-linear effects. But in a real life, in a real cosmology, in a real gravitation, you don't need it because we are far away from strong gravitational fields. That's why general relativity is a mathematics, non-linear mathematics of the Maxwell equation. And what is important, it was a genius guy who showed it 3 years later. Guys, we have the same Maxwell equation as it was before. Let's go to linearize his equation and you will see immediately the Maxwell equation. You see gravity electromagnetism and the Maxwell equations too. That's why we are playing around electromagnetism, Maxwell equations. We have only different parameters. I will talk about later. Different parameters and all this stuff. But the all equation as it is for general relativity, it's a non-linear Maxwell equation, gravity electromagnetism, and another analog of electromagnetism. That's it. But all of them based on Maxwell equations. Let's continue. Gravity electromagnetism. I don't like too much this name. He gave it in 1897, as I told you, Oliver Heaviside, because electron you don't need it. Because it's only showing the analogy between gravito and electron. That's why it's combination, gravity, electromagnetism. It's better, next guys, not only me, but some other guys, they named it gravitomagnetism. It's better, electromagnetism, gravitomagnetism. It's analog, not a combination of gravity and electron. That's why electron, it's a history of this branch of physics. Electromagnetism refers to a set of formal analogies between the equations for electromagnetism and relativistic gravitation. I explained you why. Gravity electromagnetism approximates the Einstein's field equation in the weak field limit. What is the real life? Weak field limit. Maxwell equations vary with the unit system used. Also, the general shape remains the same, whereas definitions are changed and different constants appear in different places. We will not rewrite the well-known equation, but provide relationships between physical quantities used for electromagnetism and gravity electromagnetism. Instead of charge in electromagnetism, mass in general electromagnetism, in gravity electromagnetism. Instead of charge density, mass density. Instead of permeability, μ0, gravitomagnetic parameter μ that have the same equation. Instead of impedance Z0, he introduced impedance ZG that have the same equations. Instead of electrodynamic constant C, gravitodynamic constant C, G is a time-varying gravitational parameter. It's a very important for me, for the model proposed, by the way, by Paul Dirac, crazy guy, you know. But in 1937, he proposed this idea. I used it close to 100 years later. Okay, let's continue. Gravitomagnetism in WC. Gravitomagnetism considers not only interactions between masses, but also between mass currents. Because in our, Newton's laws, we don't have mass currents, we don't have interaction of them. But when Oliver Heaviside, he jumped on gravity electromagnetism, immediately you have, as it was, charge current, mass current, mass density, energy density, and all this stuff. I cited this paper many times. In paper, galactic rotation curve and dark matter according to gravitomagnetism wrote, most theories used to explain the rotation curve have been restricted to the Newtonian potential framework, disregarding the general relativity corrections associated with mass currents. The effects attributed to dark matter can be simply explained by the gravitomagnetic field produced by the mass currents. You see, he referred to general relativity equations. But if you will, and there are some these mass currents, mass currents here, but nobody talking about mass currents. Everybody talking about only the space curve around these masses, but where are the mass currents for this object? There is none. There is none. And it is inside. He put it in his reference. The explanation of galactic rotation curves made by Ludwig is in a good agreement with WC. What is important, and I would like to emphasize, according to Maxwell equations, there are only two measurable parameters. There are two measurable physical characteristics only: energy density and energy flux density, like vector pointing and all this stuff. That's why there is nothing else, nothing else. I finished my emotional talk, very short one. I tried in the shortest way and the simplest way to explain you the value of Maxwell equations. All our classical physics based on classical electromagnetism, electromagnetic Maxwell equations, with reformulation them in general relativity. It's a nonlinear effect. Gravito-electromagnetism, it's for gravitation, but equation the same. And even equation was written by, in the Wright's contemporary view, by Oliver Heaviside. That's it, guys. I'm ready to answer your questions about the Maxwell equations, the value of them, and how it is important to understand how physics, real classical physics, developed before 1905. Thank you so much for your patience and for my feelings. Many times I told you already, I cannot talk about this cosmology without emotions. I'm very sorry, guys. They killed the whole baby. Many times I told, don't throw away baby with the bath water. It's exactly what mainstream scientists done right now. They delayed the classical physics for more than 100 years, and they neglected it, they rejected all of this. It's absolutely wrong. They don't know history of the people, of the physics. They don't know history of these great guys, and they don't great ideas about the classical physics, about our world. One more time, sorry for emotions.
Okay, thank you very much. I do have a comment here, an administrative comment, and that is if you have a copy of the Heaviside paper, and some of this one you're talking about, Ludwig, and some of these other papers that you refer to here in your presentation, if you have copies of those in PDF, could you send those to the group? That would be appreciated.
Let me give you a comment. I use the same Wikipedia like you. Put in Wikipedia Oliver Heaviside, and I cited it from Wikipedia, simple like this.
Okay, so you
That's
don't
why
have
it's nothing unique, nothing. It's now well known because Wikipedia like a library. You can find this information and even these words I put in here. It's only my emotions and my explanations, my understanding of these words. That's why Oliver Heaviside put it, and you will see all his ideas, all his adventures, all his achievements even, and he was neglected by mainstream because he was against them. By the way, he lived up to 1925. It was already not only general relativity and this quantum physics and all this side. By the way, let me tell you, Paul Dirac, he was the guy who couldn't take this, general relativity at all. Nikola Tesla, he told many times, it's wrong, absolutely wrong. To cut medium, it's wrong. The medium has a principal value in classical physics. He was absolutely right. Nevertheless, he's crazy. Both of them crazy. because they didn't follow the mainstream physics. I'm sorry. I'm crazy too, by the way. Name me crazy too, you know. I'm not following them. On the contrary, I want to kill this mainstream achievements, you know. There is no logic. They don't talk about this well-known, even experimental results. They are not based on experimental results. They're based on some theoretical mathematical equations and solutions of them in different situations.
Well, Rutherford was another person who didn't really accept the relativistic systems, and his pupil Soddy as well. In fact, on one occasion, it was said, Anglo-Saxons can't understand relativity. And Rutherford said, that's right, because they're too smart.
You're absolutely right. He didn't accept it, I know. Oh, there are so many people they didn't accept, even Planck. Oh, he invented this jumping of this electron from one level to another one. Absolutely wrong. He was classical physics. He used statistical thermodynamics. He used some equations from who? Boltzmann. That's it, simple like this. They put some pressure on his equation, and he found all the proportional coefficient between frequency and energy. He put this H as a constant. That's it. From thermodynamics, statistical thermodynamics only. There was no quantum physics. Oh, he invented quantum physics. No. He didn't accept this quantum physics too. Einstein, he didn't accept this quantum physics too, because God, he's not playing cubics, you know, he told many times. That's why, guys, we must recover classical physics. I'm in favor of classical physics. As I told you many times, there is a difference. Quantum physics, single object. Electron, proton, whatever you invent, whatever you will tell about it, I don't know, it's up to you. But classical physics, it's ensemble of these quantum objects. And we, classical objects, our life and our objects around, they're classical. We can use classical physics for our life only. For space, for time, for everything. Even space and time, it's a classical notions, because you can put them only when you have already medium. Cosmic medium only. If there is no cosmic medium, there is nothing. This is the main point of my model. Forget about it. Don't ask even question. What was a T0? No, I don't know, because there are no T0 in my model. And the same story. I don't know. I have no words against them. You know, all what they're talking about, these mainstream guys, it's absolutely wrong. It's absolute, any notion, any equation, any point they put, they're absolutely wrong. They don't know classical physics at all. They are trying to put, by the way, they did invent even new notions in quantum physics. You have the two parameters. I don't know why we have this wavelength equation for quantum physics, why we have H, why we have C inside of it, why we have mass of electron inside of it. What the hell is going on? The equation is a classical notion. You have your equation, only you have your some space, you have many particles inside of it. That's why, you know, and everything absolutely wrong, guys. For the last 50 years, nothing invented. They're only trying to accommodate, to adjust the general relativity to new results. And now they came already to the limit, to GWST. They killed their theory at all. There is nothing to talk about. Nevertheless, they continue. Oh yeah, we have already 20 parameters. We will put additional 10 parameters to explain these new experimental results. What kind of theory we have if we have all the parameters adjustable? In my model, there are only two dimensionless parameters, alpha and q, and all the other parameters depends on this one. Simple like this, two parameters only. And they have 20 plus parameters, and nevertheless they have to put new one to explain some new results. They cannot fit it inside of this general relativity. We must cut it, we must reject it. It's a wrong way to go.
Yes, that's certainly one very important point. But there's another one which I think I raised yesterday, that classical physics was generally in accordance, developed in accordance with classical logic, Grecian logic, if you like. And now, modern physics isn't. So, in other words, in classical physics, if you came across a paradox, that basically disproved your theory. You said there's something wrong. We have to start from scratch again. But that's not a problem with modern physics. You say, well, we just have to rethink it or change the way you think in your mind. No problem with paradoxes. So that's a fundamental difference between what I conceive of as logical classical physics and illogical modern physics.
You're absolutely right. You're absolutely right. And what is important? At the very first course of my studentship, I remember this, law, logic law. To prove something, you must confirm everything. To neglect something, you need only one point and then cut it. For general relativity, we have so many critical points they cannot explain. Not only one. Even one is enough. Microwave background radiation, you have it. Forget about vacuum. You have intergalactic plasma, you have fast radio bursts. Neglect your vacuum at least. And these infinities in physics, that's unacceptable totally, guys. Infinite energy density, infinite speed of this space expansion. It's mathematics, only mathematics. Paul Dirac, by the way, he told that he hates these infinities. And there is such a procedure in quantum physics to extract one infinity from another one and to have some normal, ordinary number with 8 digits after the comma. Can you believe it? Re-evaluation they have. I forgot the name of this procedure. When Dirac he saw it, I read a big book about the Dirac. It's about 500 pages. He hated it. When he saw on a blackboard this infinity minus infinity equals some real number, he put his hand and go get away. It's exactly our new mathematics, to subtract one infinity from another one and to have a number with 8 digits equal to some experimental result. Can you believe it? I don't. Guys, I'm very happy that we heard today the ideas of Andy. Let's continue with guys who can produce some new ideas, some new models, something like this. Let's see what kind of our choices, what we have around. Let's invite all these dissidents maybe against our contemporary physics, modern physics, and let's listen to them. Maybe we'll find something useful for us, because it's very important. What I'm asking only, notions, you must put the notions, what do you mean, and logic. Today, James, he told, there is no logic. It's unacceptable total. Logic, it's only one instrument to follow. Then you have some assumptions. Okay, you have some assumptions. Accept it as it is. And then follow his assumptions, and with logic, see it's correlate with assumptions or not. That's why any theory, you must start with assumptions. And it's exactly to your point too. Assumptions. Put a few sentences only, 1, 2, 3, like I have in my model. This is assumptions. You can be against it, you can, but accept it and then follow them. See, do we have a logical development of this assumption or not? Or is this illogical? Then stop it immediately, cut. There is no value of this new model based on this assumption. Propose new assumptions and all this stuff. It's a standard way to develop any model, any classical physics. Assumptions and so on and so on, That's why, guys, I'm so happy that Harry, he invited me today to do these 2 very important presentation in the shortest and simplest way to explain you how far away we are right now with the modern physics against classical physics. Let's come back to classical physics because 1905, and let's find some other genius guys who developed their ideas 300 years, 200 years, and they are forgotten. Or maybe they don't know even them. Because now education, it's only modern physics. People, they don't know classical physics because it's old. For code, it's not a contemporary modern physics. It's something, obsolete. We can't it. On the contrary, we must recover it. Don't throw away baby with bath water. Bath water, they moved it out and they moved classical physics as a baby out of the physics.
All right, Vladimir, we're under a minute now.
Okay.
Okay, I just want to mention, looks like I'm planning that we're not going to meet next Sunday because of the holiday. Probably the next meeting will be January 5th.
Okay.
Thank you, Vladimir, for talking. Andy, I appreciate you coming by and presenting to us. Thank you for doing that.
Yeah, I enjoyed it. Thank you.
Okay, guys, Merry Christmas to all of you and Happy New Year. Hopefully we'll start a new era in our classical physics and our cosmology meetings.
And the very same to you. And to all of you.
Yeah, Merry Christmas.